Hello Snowflake engineers and welcome to the video. If you don't know me, I am Sujit Nair, a cloud data architect. I am also a Snowflake Snowpro certified professional. In today's video, I will be covering certification question related to Snowpro. Let's begin.
What type of function can be used to estimate the approximate number of distinct rows from a table that has trillions of rows? Now, I'll give you a couple of seconds to try and answer this question. If you need additional time, please pause the video. And the right answer to this question is HLL or hyperlog log. Now, let's try and understand before we jump into the demo as to why this function is needed. Now, some of the Snowflake tables, they are extremely large, like they could have trillions of rows as is stated in this question. And if you wanted to know the number of distinct values and if you ran a count distinct on it, it would take a lot of time and also it would consume a lot of compute resources. So what Snowflake has done is that it has come up with a bunch of estimating functions which give us a close approximation of the actual distinct values without actually running the distinct query or whatever actual query on it. So now let's take a look at the demo. To begin with, what I'm going to do is that I'm going to first alter the session and make sure that I set the used cache result to false. The reason I'm doing this is so that the query times that I have from running these are accurate. Now, what I'm going to be doing is that I'm going to be using the customer table from Snowflake sample data. I'm going to add a limit of 10 to this for us to see. There are about 150 million rows in this table. As you can see here, there are 150 million rows in this table. And the first thing that I'm going to do is that I'm going to do a distinct count on the cust key. So let me do that. So as you can see, this execution process is taking a bit of time and it took a total of 7 seconds in order to give me this answer of 150 million. Now what I'm going to do second is that I'm going to use the HLL function in order to achieve the same thing, and let us see how long it takes. Now in this particular case I got the result back in 482 milliseconds as against 7 seconds earlier. Also, this process would have consumed much less compute as compared to the earlier query. And as you can see here, it doesn't give you the exact accurate answer, but in a data set of 150 million, 148 million, 6,800,000 is a close approximation of what we are looking for. So if you had a table that had trillions of rows, if you had run a cast distinct on that, it would basically take hours for it to run. Whereas this HLL function can return that answer quite quickly. So the function HLL saves us time as well as compute resources, especially on extremely large tables. Now, for our understanding and for utilization in the exam, there is an alias of HLL called approx count distinct. Now, HLL and approx count distinct are exactly the same. They are just aliases of each other. And if I run this query, they will both give exactly the same result, as you can see here. So for all these reasons, the best way to get the required answer is to use HLL.